All right, today we're going to talk about the remainder and the factor theorem. We use these to determine if an expression is a factor of another expression. Now, we've been doing some long division and we've been doing some synthetic division, and this can work in replace of those, but it does also work in tandem. So we will be able to use some of those skills, but just watch as we walk through these. You may be able to help yourself as we continue to divide, whether it's long or synthetic division. So in this particular case, we are asked to determine if the factor f of x equal to x to the sixth power plus x to the third power minus 2, then what is the remainder if it is divided by x plus 2? Now, we could go through all of the trouble of dividing this through the way we know how, but in this case, we're not asking for what it is divided by, but what is just simply the remainder. So we can do a thing that's called synthetic substitution, or we can just use our substitution. The way we do this is the same way that we solved with synthetic division. We take the divisor, which was, in this case, x plus 2, set it equal to 0, and we are going to see what comes out when the number negative 2 goes in. So as we go through this, what I'm going to do is simply go back to my function, f of x, but I'm not going to do f of x, I'm going to do f of negative 2. When I plug in that negative 2, it's going to show me what the remainder is when this number is run through. So let's take a look and see what happens. Remember to use parentheses. We go negative 2 to the sixth power plus negative 2 to the third power minus 2. And what will happen after we do this is we will know what the remainder would be if we had divided this in. So negative 2 to the sixth power is positive 64. Negative 2 to the third power is negative 8. And if you put this in your calculator and you're wondering why you ended up with a negative 64 instead of a positive, it's because you did not use parentheses. We've got to remember to use parentheses anytime we do these values. So 64 minus 8 minus 2, that's essentially 64 minus 10 is 54. So we know that when this number is divided by this number, we will have a remainder of 54. It tells us a couple of things. It tells us that this is not a factor of that number, but again, we also know that this is a factor of 54. I mean, a remainder of 54. So in this example, we would do the same thing. We would need to know if this is a remainder theorem. When divided by x plus 7, the number we would be substituting in is 7. So this would read 2 times 7 to the third power minus 5 times 7 plus 4. Now I'm going to do this an alternative way just because it's a little faster, a little easier, and it's less work for me. So what I'm going to do instead is I'm going to go to my y1 equals, and I'm going to type in my equation, 2x to the third power minus 5x plus 4. And I want you to do the same thing here. So we type this into our calculator, and we are going to, instead of plugging in the number 7, we're going to reference the number 7. What does 7 equal? What is the y value when we plug in 7? Because that's going to be the remainder as we look at these. So as you can see, I copied over my table, and the result when 7 goes in is 655. So that would be the remainder for this particular expression, when divided by x minus 7. Okay, this one's probably the trickiest one of the day because we are given a k value. We're giving a missed value that needs to go into this right here. So it's really the same process, except for we are given the value that it's going to equal. In this case is 95. So let's read. It says, given this function, 2x squared plus kx plus 15, and the remainder, when f of x is divided by x plus 8, is 95. What would the value of k be? So essentially what they're telling us to do is to plug in the value 8 into our equation. So that would be 2 times 8 squared plus k times 8 plus 15. Now it even goes one step further though, and it tells us that our remainder is 95. So we can actually replace this side with 95 because that's what we're told. So I'm going to go ahead and do some of this math as we go. 8 squared is 64. I'm going to rearrange the k and the 8 here so it looks like that. And then the 15 does nothing yet. So now you can see, after replacing the x's, the only variables we have left are the k values, the k value. There's only one of them. So we are going to solve for that k. 2 times 64 is 128 plus 8k plus 15. These two values are alike, so they could be put together, making 143, not 7, 143 plus 8k. The key to this, as usual, when we're doing any kind of substitution with powers, is to make sure you started with parentheses. In this case, our number was positive, so it didn't really matter. But if it was negative, it's very important that we keep it in parentheses because the sign change will usually happen here. So now we have a negative 48 equals 8k. And we finish this thing off by dividing by 8. So the k value, which would make all of this information true, would be when k is equal to negative 6. Kind of a unique question there because we are substituting in for x in order to find k, and a lot of times we're looking for x all the time. But in this time we substitute in. Left side can seem a little funny because we substituted in an 8 and then we replaced it immediately. But they told us to. That's what that means. Remember, the remainder is whatever the function equals. So we know that it equals 95 in this case. All right, as we take a look at this one, it says, which of the following function has a factor of x plus 7? And then it gives us a list of 4 different examples. If you don't know what I'm going to do with this example, with all of these functions, you have not been in my classroom. We're going to graph this thing. All right, you know that's what we want to do. It makes life much easier on us. So we're going to graph each of these functions and see which one of these answers will come out. Now, one thing I would check normally, because I don't want to just randomly graph things, if there's one of these trail terms that 7 does not go into, it cannot be the correct function. So make sure that we don't check those. About erased my example here, but we'll get right back to that. I'm going to go to my calculator and put a few of these in. I'm also going to kind of use a guessing technique to see which one I think it might be. I'll come back with you on these. Well, so I'm going to check the answer D actually. So I plugged in the answer D, and then I looked up negative 7, and you can see that it's equal to 224, which means that this one is not an equation that has a factor of negative 7. Now I want you to be very careful. I'm going to show you another picture real quick. So it's important you understand what we are plugging in. So here's what I wanted you to see. If I would have looked up the positive 7, it does have a 0 value. But again, we are not looking up the positive 7. We're looking up negative 7 because it is the x plus 7. So always be careful of those particular things. Now what I'm going to do is, since it's easy to just change a 63 into a 56, I'm actually going to check C next. So I'm going to go to my calculator and do that. So we see answer C, the negative 7 has a 217. So that one can't be the correct answer. And the thing that's nice about this is I don't have to keep erasing stuff. I don't have to keep changing my screen because negative 7 is the only one I'm looking at. So let's check answer B. So as we look at our equation, or our table, excuse me, for equation involving B, it does have a 0 for y at the negative 7, which means x plus 7 is a factor to this equation. There's no need checking answer A because we can only have one correct answer. So this is how we can use our tables quickly. The alternative would be to plug in negative 7 to each of these x's and see which one becomes 0. I very much suggest against that. So use your calculator graph, and remember, keep in mind the factors are the solutions, and the factor should always have a y value equal to 0. You have an assignment on Delta Math, so good luck.